Okay, so let's finish this problem in this discussion.
In this case, we're also not told what our final position is, so we'll come over here and say x is question mark. Then the next piece of information we collect is the initial velocity, and in this case, we were told the initial velocity is 22.2 meters per second, and I'll give that a velocity of a shorter length arrow there, because we'll want to make the arrows bigger as we go further, and my final velocity is 30.6 meters per second, and we'll make that a larger arrow, and we'll make our intermediate one intermediate size. So we're accelerating, we're increasing the lengths of our velocity vectors, and we're doing this in the positive direction, right? The larger one is in the more positive direction than the shorter one, and so that means our acceleration also has to be in the positive direction. Okay, I use my velocity arrows to tell me what the direction of my acceleration is, and it's positive because we're speeding up in the positive direction, and I've been told that my acceleration is 1.6 meters per second squared. So just write this information down now. This is my given information. x0 equals 0 meters. I don't need to write down unknown information. My initial velocity is 22.2 meters per second. My final velocity is 30.6 meters per second, and my acceleration is 1.6 meters per second squared. Okay, and then I've been told that I need time. How long does it take for this acceleration to occur? Okay, so then I go and create a formula, and the only formula I know that has acceleration in it is acceleration equals the change of velocity over time, which is the same thing as my final velocity minus my initial velocity divided by t. That's the only acceleration formula I know, so that's the one that I have to use. And you might say, well, Marshall, how do I solve for time then? And you can either plug the values directly into this formula, or our practice is always going to become, we're going to isolate this variable, and then we'll plug the values in. So if I want to get t by itself, I'm going to have to first multiply both sides of the equation by t. That'll give me ta equals v minus v0. And then I'm going to divide both sides of the equation by a, and that's going to give me t equals v minus v0 over a. Now, the quicker you can learn how to do all of this in your head, the less steps you'll have to write out. Okay, but as long as you need to, certainly write out all of those intermediate steps. And then now we've got a formula we can just plug our values into. So I write out solve t equals, my final velocity was 30.6 meters per second. My initial velocity is 22.2 meters per second. And we're dividing by 1.6 meters per second squared. And this gives us a time of 14 seconds. Okay, we don't really need, we don't really need this information anymore. Let's just get rid of that. And so this would be the solution that I want you to write down on your worksheet. Okay? So with that, I think that's the end of the lecture, but I'd go back to the video that we were doing. This is just a video clip that shows the solution to this problem. That's it.
Okay. So you can see that that is in fact the end of the movie or the video or the the problems and the notes. For the last two problems, we've also got direct solutions here. Just if you want to go back and review the solution itself, you can go back and do that. Some of them will be a little messy. Okay. Anyway, that's it for 1.3. So in the next two discussions, we'll spend some time looking at how we create formulas to solve our problems, and then we'll look at how to use those formulas. Okay, so that's it for this.